In this video, we're going to learn how to graph a system of inequalities. So what happens if instead of having one inequality, we have more than one, and we're asked to find the region that satisfies both? Well, just like when we're graphing a normal one inequality, you're first going to think about it as though it were an equation and graph both of those boundary lines. So go ahead and pause and do that now. Graph the boundary line for y is less than or equal to negative x plus 5, and the boundary line for y is greater than 2/3 x minus 1. All right, so I like to start just by dotting my lines out, because if it ends up being one that is not equal to, that's just less than or just greater than, then I'm not going to want to have it all the way drawn in. So in green, I dotted out y is equal to negative x plus 5. Since it's going to be less than or equal to, that means that or equal to means that I can actually draw that line in. And for in blue, I did y is equal to 2/3 x minus 1. Since it's just greater than, though, I'm not going to get to draw this one in, so I'm going to do a dashed line instead. Okay, so now I need to think about which solution region is going to work. So there are 4 possibilities here. I could have this region right here. I'm going to call that region number 1. It could be region number 2, which is this whole section here. Covers a little bit of each quadrant, that one does. Could be solution region 3 or 4. Hopefully you can see how my 2 inequalities have divided up my graph into 4 sections. It's not the same as the 4 quadrants. And so I need to figure out which of those 4 is the correct one. So what I could do is I can test a point from each quadrant in both of the inequalities. All right, so I've picked 4 points here. In quadrant 1, I'm going to test 4, 4. Right here, 4, 4. Test in the first inequality, 4 is less than or equal to negative 4 plus 5. That is not true. I'm not even going to bother checking in the other point because it doesn't work for one of them. I'll move on to the next one, 0, 0. So now I'll do 0 is less than negative 0 plus 5. That's true. What about 0 is greater than 0 minus 1? Ooh, those both worked. So I think it's going to be this region right here. I'm going to test the other 2 just to be sure. So 4, 0. All right, so 4, 0 did work in the first equation. So I'm going to check it in the second. So that would be 0 is greater than 2/3 times 4 minus 1. I can tell by looking at that that's going to be 8/3 minus 1. 8/3 is definitely more than 1, so that's definitely going to be bigger than 0, so that one doesn't work. And then I test my last point. So 0 is greater than or equal to negative 10 plus 5. 0, sorry, is less than or equal to negative 5. No, that does not work. Not this point. So we've eliminated all of them except for this solution region right here. Okay, so that's how you graph a system of inequalities. Now, you may notice that this one was a less than or equal to. And here, all the points below the green line work. Maybe I should use a different color for that. All the points below the green line work. And on this one, it was y is greater than 2/3 x. And so it was all the points above the blue line. Just make sure you're thinking above and below in terms of the y-axis when you think about that. Okay, I want you to go ahead and make a rough sketch of this system here. We've got a parabola and a line. And I would like you to count how many solution regions there are. You don't know the equations for this, so you don't know which one's correct. But I want you just to count how many different possible solution regions are there. Do it now. All right, hopefully you counted 1 up here, 2 down here. 3 is this big space down below, all of that. And then 4 and 5 will be here. Now 4 and 5 are actually sort of connected, but we can count them as being separate regions because they're not actually touching and they never would touch. All right, so let's say that the equation of the parabola, or the inequality for this parabola, is y is less than or equal to x squared plus x minus 6, and the line is y is greater than 2/3 x. I want you to figure out which of these solution regions should be shaded in, and it could be more than one. So try and logic through it first, thinking about the greater than or less than. Once you think you know which one it is, test a point from that region in both inequalities to verify that it works. Do it now. All right, so did you think about the fact, I'm going to do the parabola in green, that if this is less than or equal to, then it's got to be things below the parabola, which will mean anything on the outside, out here, works for the parabola. So sections 5, 4, and 3 would all work with the parabola. And for the line, we need to be greater than 2/3 x. So that's going to be anything above the line. So 5, 1, and 4 would all work with the line. So according to my logic, that would mean that sections 5 and 4 are the ones that work for both. 2 is special because it works for neither, which doesn't actually count for anything. Sorry, 2. So in this case, there are 2 solution regions, both 5 and 4. Now I want you to do one more thing with this. I want you to try and figure out how could you change these equations so that number 3 was the solution region for both. How would you change those inequalities? Well, we know the parabola already works for 3, so we don't need to change that. Instead, we would just need to change the line. And so instead of being y is greater than, it would need to be y is less than. And then that would make 3 work. And of course, you should have tested a point for both 5 and 4 to confirm that they both work. I'm not going to show that just to save time on the video since I showed a bunch of checking on the last one. Okay, now I want you to try it on your own. This time, you're going to graph an absolute value and a line. Graph them. Decide what the solution region is. This one's a little bit tricky. Take your time. Did you get this for your absolute value boundary? Remember, our strategy for that is to make a table, unless you did the extension last week, in which case you know how I was able to do it without making a table first. And then you just plug in some points. So you would plug in 0 for x, 0 minus 3 in absolute values, minus 1. That would just be 3 minus 1 is 2. So when x is 0, y is 2, etc. And then we also have x is equal to 4. Well, we haven't done a whole lot of these. We probably should have this year. So we know that that's just a line where x equals 4. So, and I can tell it's going to be an or equals to, so I'm just going to make it a solid line right off the bat, like that. And since it's all values, x is less than or equal to 4, then I know for this one, I'm going to be shading below. And for the absolute value, that is y is greater than or equal to. So I'm going to guess that those are the points above. Like so. So then what's the region that works for both of them? To me, it looks like it's this kind of strange trapezoidy thing right here, which of course would continue on infinitely off the graph, but it's got this interesting little corner piece. Oh, and I forgot to finish my inequality. Since this is not an or equal to, it's going to be a dashed line for the absolute value there, like that. And then I will test a point. So I'm going to test the point 2, 4 for x and y. So we get 4 is greater than the absolute value of -1 minus 1. So 4 is greater than 1 minus 1. 4 is, in fact, greater than 0. That works. And over here, I just plug in 2 for the x. So 2 is less than or equal to 4. That also works. We did it. Now, if I did actually want to make this a closed polygon, I could throw that line in there and then say that we have to shade below. What inequality would that be? Because we can have 3 inequalities here. To get that one, we would just need to add in that y must be less than or equal to 9. And we'd have 3 inequalities that bound this little quadrilateral there, which is not a trapezoid because trapezoids have to have at least one pair of parallel lines, and this does not. Okay, for your practice problem, I'm giving you 3 inequalities. I have graphed them for you. You're welcome. I've even identified all 7 of these possible solution regions. I want you to tell me which of those 7 is the correct region to fit with all 3 of these inequalities. Which one region works for them all?